Hi guys, it's Mrs. Cameron here, and today in class we had a bit of an SAT boot camp here at our school, and my topic today was topics in advanced math. So I went to the College Board website, and I found this PDF online that has all the different examples for the advanced math section of the test. There would be 13 to 15 questions similar to these on the SAT. That's what we would expect to see. So if we look here at question number 1, it says, in the equation above, b is a constant. If the equation is true for all values of x, what is the value of b? So I can see a couple of ways that we could start this question. If you were here in Bootcamp today, what we did was, let me pull this over here and pull this over. We took this equation that's on the right and copied it over here to the Desmos calculator. And if you have your copy of this from class, you can follow along. Otherwise, you can just Google SAT practice PDF advanced math or passport to advanced math, and you can find this page. And if you were in my class, I think I gave you a QR code that'll bring you to this. It was on page 3 of your little handout. So when we type this in, we have x, I don't need two parentheses, x squared plus b, and I'm going to add one thing. I'm going to say b times x, because b and x, when they're sitting together like that, they're multiplying, minus 2, close parentheses, new parentheses, and x plus 3. And when I come here, I'm going to take the other side of the equal sign, the other side of the equation, which says x, here's my to the power of 3, plus 6x squared plus 7x minus 6. So from right here, what we can do is we can back solve this question. We can look on the graph. I should have a purple graph here. And I'm going to go home, and there it is. There's my purple graph. And I don't have a graph for this. I have an error code because it says you have too many variables. It's not going to graph it with a B. So I would need to back solve. So I'm going to look at option A on the practice test, and it says a 2. So if B was equal to 2, then it would be 2 times x right here. And that puts my graph pretty close to my purple graph here, but not exactly on it. So I'm going to leave everything here. I'm not backing anything out because this is SAT. It's a timed test. And I'm going to switch it over to the 3. And did you see what just happened? My graph that was next to it, my green line, moved directly on top of my blue line, which means that these two equations are equal when x equals 3. Or when b equals 3, when b equals 3. But not when b equals 7, not when b equals 9, not when b equals 2, but only when b equals 3. So for this question, we have our answer right here. And then I'm going to scroll down to example number 2. Says, which of the following is equivalent to 16 s to the power of 4 minus 4t squared? And I'm sorry, I'm getting a little bit annoyed by this right here. So I'm going to pull up another tab. Not this one. I'll pull up this tab. Desmos graphing calculator. When you pull up your Desmos graphing calculator, make sure that it looks like this one here. And this way I can share the screen. Okay, sorry about that. And example number 2. So when I have this, I'm going to use my pick a number strategy, or I could use my graphing strategy. Either way, I'll find the correct answer. So if I use the pick a number strategy, I'm going to say every time that S is equal to, I'm going to pick a number that's not 0, 1, or 2, and not a number that I see on here. Okay, so a different number from any other number I see. So I'll say S is equal to 5 every time, and I'll say that T is equal to another number that's not here. I'll say 6 every single time. Okay, so you have 16 times S to the power of 4 minus 4 times T to the power of 2, or T squared, okay? And I said every time I see an S, I'm going to make it a 5. And every time I see a T, I'm going to make it a 6. And now I have this number. Now I'm going to try answer choice A, and I'm going to plug in 4 times S squared minus T times 4S squared plus T. And again, every time I have an S, I'm going to make it a 5. And when that 4 and that 5 are next together, that 4 and that S, they're multiplying. So I'm going to put in this multiplication. And every time I have a T, I'm going to plug in a 6. And these numbers are not a match. So I know that A is not the correct answer. Then I can try B. We have a 4, and this has another times 4 right here. But there's not a 4 here. Back that out. These two numbers are not a match. So I know B is not the correct answer. And then answer choice C has most things the same, but this number's changed to a 2. And this is 2 times X, or 2 times S. And look what happens when I try answer choice C. I got the same number for both. So I can box this up, and I know that's my answer, and move on to the next question. Number 3 says, which expression is equivalent to xy squared plus 2xy squared plus 3xy? When I look here, I can see that these variables are exactly the same as these variables, which means that I can do something that you probably hear your math teacher say. I can combine like terms. Because the variables of these two pieces of the polynomial are exactly the same, I can combine them. And my question to you is, what is the invisible number that's in front of this x right here? It's our sneaky one. And 1 plus 2 is 3xy squared. The variable stays the same since we're just adding. And this cannot be combined with my other two pieces of my polynomial, because what is the y missing? It's missing that exponent, so that stays at the back. And now we have our answer to example number 3. And I'm going to go ahead and cut this video here, and I will catch you back on the next piece of this in a few minutes.